Hi, this is Dr. Don, and I have a problem I want to show you how to solve using Excel with the PHStat add-in. It really is a quick and easy way to solve these kinds of problems. This is a problem that has to do with a distribution, and it's a sampling distribution. We have a random sample of 144 observations drawn from a population with a mean equal to 50 and a standard deviation equal to 48. And they want us to find the probability that the mean of the sampling distribution x bar is less than 44, is greater than 58, or falls between 44 and 60. And they say, here's your normal curve areas. Well, folks, we're not going to use the table. We're going to use technology. It's a lot faster and you make fewer errors. When you look at this problem, notice that we've got an n of 144. And remember, our rule of thumb for using the Central Limit Theorem to help us solve these problems is that we need a large sample, which we define as something 30 or greater. So this qualifies. We've got 144 observations. And if we can use the Central Limit Theorem, remember it is not particular as to what the population distribution is really like. It doesn't have to be a normal distribution. The sampling distribution will be approximately normal. And so we can use the normal curve areas to solve these questions. And from the Central Limit Theorem, we know that the mean of the sampling distribution, x bar, is equal to the population mean. And I went ahead and started my Excel spreadsheet here and put in the population mean, population standard deviation 48, and our sample size of 144. Well, from the Central Limit Theorem, we know that the standard deviation of the sampling distribution of the sample mean, x bar, is equal to sigma over the square root of n, the population standard deviation divided by the square root of n, which gives us our sigma sub x bar, or again, the standard deviation of the sampling distribution. And in Excel, I just put in a formula, and I'm going to just double click on that just so you can see again. It's equal to B10, which is sigma 48 divided by the square root of B11, and that gives us a sigma sub x bar of 4. So now that we have the two pieces of information we need, we can use the normal curve areas. But again, we're not going to use the tables. We're going to use technology. So I'm going to go to add-ins, PHStat. Here's probability and probability distributions. Click on normal. And we get this dialog box. We need to put in our mean of 50, our standard deviation of 4. Okay, the first question is find the probability that x bar is less than 44. And I use my good old StatCrunch to draw a sketch for me. And here is our distribution, mean of 50, standard deviation of 4. I put in an x bar location of 44. Of course, StatCrunch gives me the probability, but we're going to let PHStat do that. So I make sure that's checked, and I put in 44 to get this first answer. The next question is find the probability x bar is greater than 58. There's my sketch from PHStat, greater than 58. That's that red area over here, the far right side. So I need to check that in my PHStat and put in 58. Third question, find the probability that x bar falls between 44 and 60. Got my PHStat sketch again, between 44 and 60. That's this area in red there again, from 44 on the low side to 60 on the high side, and it's the area between. So I'm going to check that for the range of 44 and 60. Next, I'm going to get these last two pieces of information, which you don't need for this question, but I just want to show you how it works. I'm going to click on X for the cumulative percentage below 95, and that's this sketch over here. What value of x bar has 95% of the area under the curve to the left of it? And that's from the left infinity to that point there. That's this sketch. And last, I'm going to select this one, the X values for percentage, and I'm going to use 95 again, but this time it's the area between two values of X bar. 95% is the area under the curve there in the sketch from StatCrunch, and that's what we're trying to find. What are these values of X bar? And I'm just going to go ahead and click OK, and we get a lot of information here, which is really very handy. And this is a simple Excel spreadsheet once it prints it out. Information that's highlighted in blue are values that we input. And one of the neat things about this, if you save this worksheet, you can go back later and change. Let's say that we've got a problem with a mean of 58, and it recalculates everything. I'm going to go ahead and put that back to 50. Same thing, you can change the X values here, less than, greater than, in between, and then the probability for the ranges you can change, and then the percentages as well. So you can reuse this without having to go through the whole dialog box there if you want. But anyway, it gives us the first question, values, the probability for getting an X bar less than 44 has a Z value of minus 3.5. Whoops, I'm sorry, minus 1.5. I had to recalculate from when I changed it there. A 0.067. The probability of an X bar greater than 58 has a Z value of 2, since it's on the right side of the curve, if you remember. And the probability on that right tail is 0.023. Probability in the range is 0.0896, and it gives you the information here for that range. And I'm sorry, this is the area in the tails, less than 44 or greater than 58. I forgot that it gives you that, 0.0896. And down here is the inclusive range from 44 to 60, or from a minus 1.5z to a plus 2.5z. Gives you the probability for less than, which is 0.068, less than 44, probability of less than 60, both of them the left tails. So you can subtract that from that to get the probability in between of 0.923. Down at the bottom, it's given me my left tail, everything under the normal curve for this sampling distribution. 95% of the values of X bar would be less than 56.58. And then here, if we wanted the area between, 95% of the values of X bar would be between 42.16 and 57.14. So it's a pretty useful little tool, and I hope this helps.